I see who attended my workshop the past 2 days. I see quite a showing here. Thank you for day 3 of hanging out with me. That's awesome, and that's a great sign, I guess. You didn't abandon ship. So we are going to talk about cloud native. So the title of this talk, with this extremely bright light, is "The Future of AppSec is Cloud Native." I have went through a slide transformation where all my backgrounds are open source photos, so they keep me entertained. Hopefully they're fun. My name is Jimmy. I'm actually strangely not affiliated with any company at this particular day. So it's just me, and I have some job changes coming up in the future that are pretty exciting, but for now, I'm here representing myself. I live in Arizona, the snowy, cold part of Arizona, so Flagstaff, so it's not hot. And this is my first NDC conference, so thank you very much for having me. This has been an amazing experience. I wish I could see more of it and not be working for 3 days, but I'm here today talking about cloud native. So first things first, the schedule for the next hour or so. We're going to talk AppSec, what it is, what it was, where we're going with it. I have traditionally been in application security roles, pen testing roles, red and blue and purple, all of these things over the years, so things are changing. Then we're going to talk about DevOps, how that introduced a small twist into what we know of as AppSec. Then kind of the meat of the talk is cloud native, right? Who here has heard of this word or phrase, cloud native? Who here is using cloud native tools and methodologies at their work? Maybe, or don't we know? I'm not sure if I am either, right? So we're gonna clear some things up. There's a lot of buzzwords flying around the industry right now, so I'm gonna try to stay away from those as well as commercial tools. And then we're gonna jam everything together into what we're gonna call Cloud Dev AppSec Ops Native, right? That's kind of what we're dealing with today. And if you follow me in any way, shape, or form, it wouldn't be a talk that I give without discussing Kubernetes. I can't get away from it. It's followed me for the past 4 years, and it's gonna follow us into this room. So we're gonna take kind of what we talked about and discuss how Kubernetes is kind of the poster child of cloud native, right? And how Kubernetes has embraced some of these concepts and how organizations can take kind of security tidbits as well as operational mindset when we move towards Kubernetes. And it wouldn't also be a talk that I give without talking about the downsides of some of these things. And I actually have a slide mentioning you, Erland, here with your Envoy CVE. So I didn't even realize that was going to happen today, but I think it's awesome. And then a take-home assignment, right? This is what you can do today to go kind of get a view of a 10,000-foot view of your, not just your cloud environment, but your entire organization, right? Because cloud native does not imply just technology. There's a lot more to it. So, does that sound okay? We have an hour. We'll hang out. Please interrupt me and ask questions as we go. This does not have to be extremely formal. We should have some fun. So let's start with AppSec, right? Who here does application security professionally? Me, sort of. Cool. Who here's a developer that just deals with security people every day, right? Cool. So application security, my very first job out of college 11 years ago was doing AppSec. Basically, I found an old web application firewall that we were paying a bunch of money to a vendor for that was abandoned and not in use, and I said, can I plug this in? And that was I didn't know then, but that was AppSec engineering, right? So we've come a long way since the beginning of information security, especially AppSec, and I've been on that ride for a while and really have transitioned quite a bit into what we know of as infrastructure cloud security, and there's a lot of blurry lines there. So traditionally, we had firewalls, right? And we purchased blinking boxes because vendors told us to, and we thought we were doing application security. Has anybody ever used a web application firewall, right? Have we had 100% success rate with web application firewalls? Probably not, right? But this was the early days of AppSec, right? And AppSec was just a flourishing industry. But we got more mature, right? We started pen testing. We've had formal methodologies. the OWASP top 10 really gave us this kind of methodology or set of common risks to lean on very, very hard, unfortunately, throughout the years. And we started threat modeling, right? So the advent of application security engineering really started to take shape. And more today, modern AppSec programs look like this, right? We have bug bounty programs where we're telling others, hey, hack our stuff, we're gonna give you money, we're gonna triage it, and we have more sophisticated tooling, right? Cloud web application firewalls, we have formal application security engineers, training, things like that, and everyone's saying, do DevSecOps, right? Build a pipeline, do static analysis, do dynamic analysis, and that's kind of our AppSec program. So things really started to change when the world moved towards DevOps, right? So we even look back to the book, The Phoenix Project by Gene Kim and a couple of the folks at that time who were really pushing this, forget your silos, forget your development and operations and security living in their own worlds, and let's all work together. Security, as usual, was late to that game, right? And we're really only starting to talk now about what is DevSecOps, right? How can we all do this thing together? So I was in AppSec at the time, right? I was the one doing static analysis, breaking builds, sending PDFs to developers. I'm guilty of these very horrible things that we talk about now. But we had to make a decision at this point, right? If we're going to embrace kind of this DevOps movement, tear down the silos and all the walls that we've built as far as the team of just saying no, and move into what we know of as DevOps or DevSecOps. So did we embrace it or not? Maybe. So this slide's not that important. I think it's because I'm gonna throw you a definition that I have, but I think it's funny. If we have the data, let's look at the data. If all we have are opinions, let's go with mine. So you're here listening to me today, so we'll just go with that, right? So my definition of DevSecOps that has kind of worked over the past 3 years is the process of incorporating and enforcing meaningful security controls without slowing down deployment velocity. And we're gonna kind of leave it at that for DevSecOps at least, right? And really at the end of the day, this means we're all responsible for security. So this isn't a talk about the security team versus the dev team and some of the friction that could occur there. This is really just about, if you don't jump on some of these bandwagons and new technologies and methodologies, as a security person, you will literally be left in the dust, sitting in your job for the next 5 years that you hate. And that's just, the role is changing, right? And that's kind of the future of AppSec is cloud native, at least in my mind. So cloud native, a lot of discussion about this, right? Not so much at this conference, but you go to some of the larger ones around the world, you will always have at least 3 DevSecOps talks and 3 or 4 cloud native talks, right? Who has a good definition of cloud native? I'm gonna make this interactive. I don't know if it's supposed to be, but I do a lot of training and that's what I'm used to. What's cloud native? You were in my class. Work with me. Plus I need water.
Applicational solution that is built first and foremost for the cloud as opposed to being lift and shift.
Love it. So as opposed to lift and shift, right? Oftentimes organizations will call themselves cloud native by just taking their monolithic Java application, shoving it on an EC2 instance behind an Nginx proxy and calling it a day, right? That's not cloud native, and that's actually not what we're talking about. Just because you're running things in AWS does not mean you're embracing cloud native principles, right? So software teams really have to focus on speed, agility, security, and stability. And there's no choice in that, right? If you want to call yourself a full stack developer, all of these things matter, and security is part of that. And yes, this is my future midlife crisis car, the E63, right? So I will have that someday, if my wife lets me. So cloud native is not technology. You can't buy it. You can't get it on open source GitHub. You can't just go pay a vendor for it. We're gonna definitely say that. And it's just not a set of tools, right? It's not service mesh. We'll leave that out as well. It is a set of design patterns and assisted by tooling, right? It's not just the thing you have turned on in AWS. And these patterns are actually really, really powerful, right? Because the whole point is to move faster, and the whole point is to move faster with confidence and being able to roll back and being able to do all these things that help us get to market faster, right? So we're really looking at cloud native to solve that, and you should only do this if you need to solve these problems, right? So let's talk about some of the core principles, at least as defined by the CNCF. And the CNCF is the Cloud Native Computing Foundation. We're going to reference that a few times. So number one, observability, application portability, loosely coupled services, policy-driven infrastructure, automated pipelines. So I do have, I won't call them demos. I do have some things I want to flip around and share. So fair warning, we're going to leave PowerPoint land for a few minutes as we go throughout the talk, but we'll see. So observability, really important. And it is kind of taken over the discussion if you talk about SREs, right? Site reliability engineering. Those folks love to talk about observability. And really, this is fancy monitoring, fancy metrics, right? Gaining deeper insight into a system. As we move towards things like containers, Kubernetes, serverless, functions, all of the things we associate with cloud native, our systems become fairly complex, right? So observability becomes really, really important to see what's happening for debugging purposes. And that can also be part of your security story, your security program, as we'll see. Portability, this is huge, right? Cloud native implies that we don't rely on just one public cloud provider, but we should be able to take this unit of deployment, whether it's a container or a function, run it locally, run it in AWS, GCP, Raspberry Pi. It shouldn't really matter, right? And it should look exactly the same. That sounds easy on paper, but is really, really hard to accomplish. Loosely coupled services, this is what we know of as microservices. And I see people taking pictures of slides. I'll share these. I'm not sure the process to do that, but I'll at least tweet out a link to the slides in a PDF if you so wish. So loosely coupled services, and if you came to my Kubernetes workshop, we talked about this a lot, right? API-driven interfaces, and these things can scale independently, run independently, and their own deployable unit, if you will, right? So this is the advent of microservices, and really plays nice with cloud native methodologies. And policy-driven infrastructure, right? So this is infrastructure as code, or what some people call infrastructure as software. There's the whole movement away from calling it infrastructure as code. But really, we're describing our infrastructure and its components using code, right? And that's really, really important. And if you're doing cloud native, this is at ground zero. This is the first thing you have to accomplish, right? So I put together a little tiny example of this that I just built this on the plane ride over because I wanted to play with Terraform, but it's pretty simple, right? I called it Tough Cluster, but this is an example of infrastructure as code and how security and even compliance can really kind of incorporate with this kind of methodology, right? So here we have Terraform configuration files. So Terraform is a really, really popular infrastructure as code framework, and we're writing TF files to basically go build a Kubernetes cluster inside of GCP. And this defines everything we need to create a cluster that is semi-sane with security defaults. The beauty of this is that the security team has access to this Git repository, right? I can go audit this. I can go tell our PCI auditor or assess these or run linting tools or do all the things I need to do from a security perspective, but it's now code, right? And there's nothing that special here, right? This is a private cluster. We're using database encryption using Google's KMS, so we're checking a bunch of boxes there with, 3-4 lines of code. Istio is enabled, right? We have a service mesh and we have MTLS between our workloads inside of our cluster with 6 lines of code. And we're working with our KMS keyring and then some IAM policies, right? So all of this looks like 72 lines of code plus a few extras to build the network itself, the private VPC. But under 200 lines of code, we have an auditable Kubernetes cluster that can be built and rebuilt n number of times, inspected by the security organization, inspected by the compliance organization, peer-reviewed, put through its own CI/CD process. And this was like, whatever time it was on the airplane flying over here across the Atlantic, right? This isn't really that difficult, but this is the future, and this is where we need to be heading, and security teams need to understand how to read this, right? At least in my opinion. So, and you'll have the slides, but you can obviously bookmark or star that if you wish. Automated pipelines, right? Another really key component to cloud native principles and cloud native methodologies is automating everything you possibly can. If you've done it more than once, you should consider writing a script and or automation to make sure that it can be done by a computer or a robot, right? And not humans. So this is happening from the moment somebody types code in their laptop in their IDE by using git pre-commit hooks all the way to production, right? All of the automation needs to take place every step of the way. And this is something I've been thinking about a lot lately after I read this article. It's pull-based CD pipelines for security. The link's right there, but there is this kind of, it might be legacy, but this is the way we've been doing things for a long time, where we have development and then a repo, CI/CD, Jenkins, Travis CI, or Circle CI is now responsible for pushing out manifests, applications, any sort of code change, including images to container registries. We've been operating in this push world for a really long time, where we've decided to give our build systems service count tokens, secrets, passwords, all sorts of really gnarly things that don't always bode well with throwing on the internet or putting on Jenkins. So there is this kind of movement towards going pull-based, right? And this is kind of an aside to the discussion of cloud native, just because it's on the top of my mind, where we actually have our CI/CD system sitting inside of Kubernetes, sitting inside of our cloud environment, and it can go reach out and pull your GitOps repo, right? So this is a really, really great article that's a little bit scary, right? And it should be, because of these things, right? Some of the issues that live with this push-based model, and here I am telling everybody to kind of go automate all the things, but think about what tools have access to your service count tokens and your secrets, right? So secret sprawl everywhere, network security concerns, right? You're now opening up your Kubernetes cluster, or et cetera, to this build system. And I don't trust Jenkins, right? Have we ever used Jenkins before? Remote code execution as a service. It's full of holes, full of issues, and we're storing deep, dark secrets in there, right? So access control is also a problem. So that's a little bit of an aside, but it's important if I'm telling you to automate all the things. Don't just throw everything in Jenkins and assume that that push-based model is secure. So it's the combination of tools and patterns, right, that help you become cloud native. There is no final end state of like, I had, this Friday I turned cloud native. That's not really a thing. So it's really just working towards these goals, right? And running virtual machines in a public cloud, that's not cloud native, right? That's just lift and shift. That's, you're using a public cloud infrastructure as a service, but it's not really the end goal. So I came across this recently. It was an interview done a few years back with Chris Nova and Justin Garrison as they were building or writing their book. It's called Cloud Native Design Patterns, something like that. It's an O'Reilly book, but I kind of like this description he had in this random interview. It says, cloud native infrastructure is about creating reliability out of chaos and useful abstractions for applications. It forces engineers to write applications that are controlled by software and exposed to necessary operability hooks in the application instead of through typical infrastructure or human process. That's good, right? We're talking about abstractions from here on out, abstractions on top of abstractions. So in our Kubernetes kind of case study, you're going to see everything is an abstraction. Everything's API driven. We're very rarely dealing with the underlying operating system mechanisms anymore. We're dealing with APIs now. So, and I like this kind of description. So this is the, if you've ever been to the CNCF webpage, this is actually probably like 6 months old, so it's out of date. But this is what the CNCF, the tools and projects and even companies that they are representing as part of the Cloud Native Computing Foundation. So, right, if we talk about cloud native tools, that's this, right? And this should be terrifying, right? Because this is literally the thing we're dealing with. So as much as I want to embrace cloud native, there's no way that we have had security eyes on all of this, right? There's no way possible that 75% of these might have just egregious CVEs. We have no idea, right? Things are getting better. The really popular projects have been tested lately. Kubernetes, Istio, and a few of others have had some more eyes, but this is the tool set we're dealing with, and this isn't even all of it, right? So it's very challenging for us as security engineers to take this and run with it and let people use whatever they want. So the future of AppSec is Cloud Dev AppSec Ops Native. I can't even say that, right? At the end of the day, your job description's changing, right? If you're a software developer and you know nothing or refuse to learn about cloud native technologies, even if it's just AWS, you're gonna become stagnant, right? That's really hard to come to terms with. And if your organization decides, I wanna go Kubernetes, and you say, I don't care, I just write code, you better learn what's going on under the hood, right? This changes how you write software. Same with security, right? Security traditionally now feels like it wasn't that hard. I could have just ran a couple scanners, did my thing, and kind of, did my lightweight threat modeling and called it a day. But now I actually have to go read books and test things out and learn. So you should be changing your job description, even if your employer is not. I firmly believe that. And our illusion of control is pretty much gone, right? So traditionally, on-prem infrastructure, VPN inside of the infrastructure, now you're in, right? It's this gooey, horrible mess that you can traverse, and there's no authentication and no logging, but we have a VPN, right? So we're safe. That's not how we work in the cloud native security space, right? We have third-party components, public APIs. These tools are living all over the place, multi-region, multi-cloud. There is everything zero trust these days. So if you think that just because you got into your VPN that you're safe, that is changing very, very rapidly, right? And one example of kind of one of my favorite bugs that kind of brings all this together, this came out a little while ago in 2018, but Shopify, somebody found a SSRF bug in one of their web properties, right? exchangemarketplace.com. It's a $25,000 bug. It's not terrible for a simple SSRF flaw, but it just shows that AppSec is not as simple as just finding cross-site scripting, patching it, finding SQL injection, fixing it right there, right? This is a kind of a mashup of what's going on the back end, right? So who knows what SSRF is? Have you heard of this term? If you took my class, what's SSRF? You shook your head like this, yeah. Server-side request forgery. That's the acronym definition, yes? Oh, cool. Well, I'll go over it in one sentence. It's forcing internal servers to make network calls, right? Basically, somebody went to this, was testing the Exchange Marketplace, and they were able to force the server, which was a container in this instance running in Kubernetes, to make an internal network call that could hit the AWS metadata endpoint. That metadata endpoint is a treasure trove at times of all sorts of information about your environment. They were able to steal some keys, do some bad things, and ultimately take over basically all of Shopify's AWS production account, right? So traditional AppSec people might just try to stop SSRF or maybe kind of understand what's going on, but the impacts downstream to the cloud provider in this case were huge, right? That blast radius exiting out of a container in a Kubernetes cluster to owning the entire AWS account is worth probably more than $25,000, right? That's just the maximum bounty, but that's to Shopify, which is a public company that makes tons and tons of money, that's $1 million bug, right? If you own their AWS account, you could do anything. So I never thought I'd quote Gartner in my life, but I did, and I don't regret it. It's okay. I like it. Through 2020, 80% of cloud breaches will be due to customer misconfiguration, mismanaged creds, or insider theft, not cloud provider vulnerabilities. So the fear of AWS getting hacked should not stop you from moving to the cloud. It's going to be your fault, right? It's not going to be AWS's fault. 9 times out of 10, you're going to leave an S3 bucket open. You're going to leave a Kubernetes management interface open. You're going to check something into GitHub that you shouldn't, right? So as much as I don't subscribe to Gartner too much, I agree with this wholeheartedly, right? It's all about misconfiguration from here on out when we move to the cloud. And another report I never thought I'd quote. A historic 424% jump in breaches related to misconfigured cloud infrastructure, largely due to human error. This is humans at a keyboard typing the wrong thing or not knowing what to type, right? If you came to my 2-day Kubernetes workshop, hopefully you exited it with like, I didn't know some of this even existed, right? You don't know what you don't know. And it's not about blatantly ignoring security, it's just the complexity has become so great, right? And then my tweet, right? This was a prediction, and I think people took it too seriously, but that's okay. Cloud configuration overtakes phishing as top source of breach data. I agree with that as well. I mean, it's bold, but I think that cloud misconfiguration and our lack of understanding of what we're doing is going to be the source of mega breaches, right? Phishing is one thing, but misconfiguring an S3 bucket with 4.2 million records on it and opening that to the internet, that's a whole different ballgame. And then our friend Erland, right? CVE 2019, 9901. This is, and you talked about this at SecApp Dev last year, and I haven't stopped thinking about it because TLDR, I found a path traversal bug in Istio's authorization policy enforcement. So Istio is the hot new web service mesh. Everybody says use Istio, all your problems will be solved. Istio relies on Envoy proxy as a sidecar container running inside of Kubernetes. And we rely on Envoy to do a lot of security work for us, including authorization policy enforcement, right? So if we look at the bug itself, it is, not discounting you, this isn't like a 0-day kind of APT style bug, right? This is path traversal that we have literally figured out 15 years ago. I mean, this has been something that NGINX and other firewall style companies have just, I mean, this isn't a problem anymore. But now with the hot new cloud native technology, we can do this very advanced APT payload of ... And we can literally access protected URLs or protected paths. So this is insane to me that this is the tool we're relying on and telling everybody to put all their security eggs in this basket, and nobody else has submitted much since then. I think if we had more people like Erland looking at Envoy, we would find tons of more sophisticated bugs. So thank you for your contribution and making it to my slide. And I didn't even know you're going to be here, so that's good. Contractors AWS has 3 buckets, right? We've seen this. We know of this. Misconfigured data storage, especially in the term of S3, is going to continue to happen. We don't even need to talk about this anymore. It's just the reality we live in. So if we blindly adopt these patterns, like Envoy, right, and think nothing of it and just say, we're doing Envoy, we're doing security now, we have a whole new class of vulnerabilities, right? And if we just forget about the ramifications of that, bad things can happen. But I do believe if we think about what we're turning on and think about the methodologies and architecture of our cloud native environment, we can move faster, right? AppSec can now be part of this DevOps movement, right? And we can start contributing. So number one, we get a few things out of the box by just using cloud native patterns, right? Visibility outside of security, observability, logging, metrics, tracing, monitoring, all those things, you kind of get them for free when you start adopting these service meshes and some of these cloud native technologies, right? Security teams should be excited about this. The more visibility we have as a security professional and the less I have to build and buy, and I could just piggyback on what's already turned on, that's great, right? I can have my own Grafana dashboard. The data's already there. I just need to start taking it in and doing things with it. Service discovery, right? This has been a long time problem, especially in on-prem environments, right? Where I don't even know what I have running, right? I just create virtual machines and servers and all these things, and I don't know how they talk to each other. I just kind of YOLO my way through my whole infrastructure. But service discovery is a first-class citizen in pretty much every cloud-native tool chain, right? Kubernetes especially. And when you use a public cloud, they have APIs for you to just go get a full asset inventory data dump, and that's really, really powerful for security. Authentication and authorization, right? Things like the SPIFFE Runtime Environment, things like MTLS built into Envoy and Istio, those are almost checkbox kind of turn on and set it and forget it sort of protections that these were really hard problems back in the day, right? It's like, how do we do MTLS? We have to bake it into every application. We are writing things in 4 different languages and frameworks. But with this sidecar pattern and some of these new technologies coming out, we get this for free, basically, right? And every auditor and every security person, especially when you're strapped for budget and time and personnel, the more you can get for free, the better. The community I've found in this like cloud native space is actually really great. They're open to security people critiquing things, right? They're not this, it's a very different vibe than going to other security conferences. We'll leave it at that, right? So they're really pushing security forward. I don't have it listed here, but the CNCF sponsored a formal pen test and threat model of the Kubernetes project late last year, and it was welcomed with open arms, right? And it was this amazing thing. There's like 30 vulnerabilities they found. They're doing the same with other big projects as well. And at its core, cloud native is all about automation and the ability to recover. So if you have a security incident, you could take advantage of that too, right? If you understand how your build systems work to roll new objects out and roll them back and something happens, there you go, right? You're moving fast as a security organization. And then the platforms we choose themselves, they do a lot of really hard security work for us. I've worked at organizations that build their own data centers in a basement or rent out space. They're dealing with physical security, air conditioning, electrical, all these crazy things, and going to get your SOC 2 or some major compliance checkbox, like AWS, GCP, Azure, all are gonna have all those things that you need, right? And you can just leave that to the people who do it best, right? I love this tweet from Shania. I am seeing a quiet revolt against many security tools because they do not play nicely with modern dev practices, right? And I believe that, right? The security tooling industry is, scan the code, PDF report, do your thing, put a WAF in front of it, and those just, people don't want to hear it when they've already moved well beyond kind of our traditional SDLC. So, our friend Kubernetes, right? It is a big no-no to put ship pictures in your Kubernetes or Docker container talk, but I don't care because this picture actually reminded me a lot of Kubernetes. So, Kubernetes, if you're not familiar, container orchestrator, built to automate the scaling and orchestration deployment of containers. It is the clear winner in this space. If there was a race to the top of container orchestrators, Kubernetes pretty much won. And I use it as a case study because it embraces many of these cloud native patterns that we kind of just talked about, right? And it's been doing that since the very beginning. But at its core, Kubernetes is just Linux, goop, and Golang, and a bunch of containers doing what they do to basically get your workloads up and running. It handles networking and all sorts of things. But we're not gonna, this isn't a Kubernetes intro talk per se. And this is an interesting take on it from an article on the New Stack introducing the hierarchy of needs and microservices. I found it interesting that Kubernetes took up all of this space, right? We have people, DevOps and anti-fragile DevOps, and then infrastructure as a service, but Kubernetes does a lot. We're putting a ton of concerns and throwing them all into this thing we're calling Kubernetes. Things like our health checks, deployment logging, secrets management, our control plane, all this crazy stuff. We've decided Kubernetes is the right fit for it. I don't know if I agree, but it's where we're at right now. So who here thinks Kubernetes is secure by default? Hopefully nobody. Nothing's secure by default. So a few examples of the reason it's not. Old school, original Kubernetes issue. This is like made the news. I got phone calls. It was awesome in 2017. Tesla, the car manufacturer, somebody found this dashboard of Teslas sitting on the internet, and these things were in it, right? AWS S3 access key and secret access key. This dashboard had 0 authentication in front of it. So what somebody did is grab those keys, put them in their own AWS config file, authenticated to the Tesla AWS account, mined cryptocurrency, right? No one even knew what Kubernetes was, nor that Tesla was a user of this crazy thing. And everyone's like, wait, am I doing Kubernetes? Do I have this dashboard open? Help, right? It's like, I don't know what's going on here. So this was a really funny time. And then back to that SSRF attack, right? That was a hit against Kubernetes. And this is a kubelet certificate replay attack, which is pretty awesome and for a bit ahead of its time, to be honest. There weren't a lot of people doing this sort of thing, and basically the kubelet is a very privileged process in the Kubernetes ecosystem on each node, and if you steal its certificate, you can do really bad things, right? So this is kind of like mind-boggling for a lot of people because Kubernetes was new, and then this cute thing called the kubelet apparently wasn't secure, right? So this really led to a lot of conversations as well. And if you took my workshop, we walked through this, but really, really good and solid incident sort of write-up on how a cryptocurrency miner made its way to an internal Kubernetes cluster. You can go read that on your own time. So the scene is growing in Kubernetes, right? We had this really quiet couple years where like everyone's like, is this gonna take off? I don't know, people are just using this thing. Attackers haven't really done anything with it. That's changing, right? CVEs are popping up all the time, and people are talking about Kubernetes quite a bit. So I'm gonna skip this for now. You'll have the slides, but this is from a free ebook called Operating Kubernetes Clusters and Applications Safely, but some of the problems that may exist inside of a Kubernetes cluster, a little bit of a threat model. So let's talk about defense mechanisms, right? So I primarily care about defense. Stunt hacks are cool. Getting paid bug bounties is fun. But what can we do to stop kind of this craziness that's going on in Kubernetes, right? And like I said, Kubernetes is our cloud native. It is the poster child of the CNCF. There's KubeCon, which is overtaking Cloud Native Con. It is what everybody refers to as Cloud Native. So just a brief talk about the defenses that Kubernetes offers, and then I want to show you one resource that a few of us built a few months ago. So number one, RBAC. Everything in the cloud native space needs to be really honed in as it comes to access control, right? Now we're opening everything up to everybody. Service account tokens have become this thing, how we get to our clusters, how we get to our resources in AWS. In Kubernetes, we use RBAC, right? Role-based access control. And we have users, resources, and operations, and all RBAC is tying these things together in a least privileged fashion, right? Picking me, Jimmy at jimmy.com, I'm only allowed to get and list pods, right? That would be a very limited RBAC role, but it would work, right? So we use YAML to do that, and this is just an example of creating those particular roles. These are hard to audit, right? So as you build out a Kubernetes environment and somebody says, cool, like I'm a security person, I want to do a formal audit of your entire RBAC policy. It's not that straightforward, and oftentimes, quick tip, just most people put star for everything here. If you look for that and you see that, especially at a cluster role level, that's not good, right? You don't want everybody having access to every single component. So a more fun topic is that containers themselves, right, the things we deploy onto Kubernetes, can do really bad things, as it turns out, right? They can run as root, they can mount sensitive volumes, and they can bind to specific ports, and they have this special thing called privilege mode. Has anybody used this before? Privilege mode? Does it sound like a defensive mechanism? Probably not, right? Privilege is usually something we want to stay away from. But it turns out Kubernetes doesn't care. It just supports it, right, out of the box. We need to implement something to stop this, right? We have two options we're going to discuss briefly, pod security policies as well as OPA, or Open Policy Agent. So PSP is the built-in form of admission control that Kubernetes has and gives us, as security people, some assurance that bad things don't end up landing on the cluster. And they look like this, right? Pretty simple. This is a pod security policy called myPSP. And the main line to take away here is this privilege false, right? In the example of I don't want these privileged containers, which really aren't containers anymore, and we can talk about that after the talk. If you want to stop that, privilege false, pretty straightforward. And we have many, many other rules we can choose as well, including an allow list of volumes, right? So pod security policies, I've only had one customer in the past 2 years that actually used them, right? So, and I'm dealing with people who I thought would be doing better, but they're not, right? Because these are hard, right? And actually, people didn't even know they existed because it's not something that comes with Kubernetes. It's not something that people talk about. But you have to dive in deep and find this stuff and turn it on and figure out how to get it working in your own environments. So dynamic admission control, this is a really, really exciting area in Kubernetes, and this will let us intercept requests, incoming requests to our cluster, and do things with that request and mutate it, deny it, allow it, log it, whatever. So we have options such as, Kelsey Hightower made this little simple deny M validating admission webhook. So it will look at every single incoming request to the cluster and reject pods that use environment variables, if you so wish. Most of us have decided to move towards something like Open Policy Agent, or OPA. This is a basically cluster-wide configuration for your entire Kubernetes environment. It's really cool, and it is where the future is in this admission control kind of space. It is taking the place of pod security policies. And this is a form of admission control that we would use using, it's called OPA Gatekeeper. Gatekeeper is basically like a set of recipes for Open Policy Agent. And all it does is say, I only want images that come from trusted registries. I'm going to list my trusted image registries. Maybe it's Docker Hub, probably shouldn't be, but it's probably your internal container registry, and block all the other ones, right? And you do this with code. So the beauty of this is that nothing will get in once you turn this on, and you can actually go audit your cluster for offenders as well. And then we're starting to see the advent of additional sandboxing techniques, right? gvisor and kata containers. These are shims that sit in the middle of your container and the host kernel and act as a proxy to those Linux system calls, those kernel calls, and will limit what your application can actually do. If you're running your own PaaS, if you're a company like Heroku, or if you're running these highly untrusted workloads, these are really, really important to look at and understand. And then Kubernetes is just servers, right? Most of cloud native things at the end of the day aren't serverless, right? As much as the industry wants to tell us, forget about servers, I haven't seen a place that is 100% functions as a service, unless somebody is at that spot. That's awesome. Just not really the reality. It's a mix, right? So harden your operating systems, harden your configurations, use benchmarks, etc., right? Containers can do bad things, so it's always worth mentioning Falco. Falco is a container runtime monitoring tool that plays nice not only in Kubernetes, but any container-based environment. And it will look for things like privilege pods, what time is it? A shell that runs in a container, which could be bad, outbound connections, not just to Elasticsearch, but anywhere, right? Egress traffic's a big deal. Disallowed images, maybe a node port was created on the fly, and sensitive volume mounts. So keep in mind that Falco does take a bit of configuration, but once it's in place, you kind of have this really, really strong set of out-of-the-box rules you can use. So Kubernetes can be secure, but it's really not the default, right? And I do want to share one small project that we released at KubeCon last year. And it's at securekubernetes.com. And this is, and if you took the workshop the past 2 days, you did this hands-on. But this is a guided tour to 2 different scenarios. There's like kind of a beginner and advanced attacks and defenses, and it walks you through step by step on how to attack a Kubernetes cluster, what could happen if you leave a node port open to the world, how to break out of a container in 2 different ways using sensitive file system mounts as well as some host PID escalation. And it's all copy paste. So if you've never even used Kubernetes, we've set it up where you run one script, it brings up everything exactly how it should be inside of GCP. You get your single node Kubernetes cluster, and it's great for training, but it also takes away some of the ambiguity of what these attacks look like, right? Especially container breakout. A lot of people, it doesn't click until attack 2 where you're like, oh, I'm root on the node in the cluster, not in the container anymore, right? And then things really start to pick up from there, right? Where it's like a web application vulnerability escalates to full cluster account compromise. So this, it wasn't just me. There was 4 of us, Brad Giesman, Peter, Benjamin, and Tabby Sable. They're awesome, and we put in way too many hours for this, and it's working really well. So check it out if you want to give yourself 3 hours to walk through it, 3 to 4 hours. Do it with a group at your office, and I think it's pretty worthwhile. But I'm also biased. So in summary, we got to get away from just scanning our application source code with static analysis tools and then running burp suite against it, right? That's not really what AppSec entails. We have to go beyond that to the other systems that our applications are using, to all the cloud bits, to everything, to the multi-cloud third-party APIs. Our jobs are getting harder, but I think they're more interesting, right? And going forward, in my belief will be that balance of security and deployment efficiency is tough, right? It's been tough, and now it's only getting harder where our dev teams are moving really fast, right? They've embraced this stuff well before security teams, and if you decide to be the Department of No and put all of these firewalls up and gates up, you're gonna be in for a bad time. I've seen that happen. There is no scanner or firewall. There's no product you can buy. That should go without saying, but if somebody's selling you cloud-native security, don't buy it, right? This is way more than just scanning your way out of things. So it takes a lot of work. So let's apply it. We'll just take a few minutes here. I put these together to demonstrate this is not exactly what everybody's like on-prem solution looks like, but this is kind of what I dealt with a long time ago, right? So we have our application, SaaS app, whatever, firewall, we have some sort of proxy, app server, database, 3-tier architecture, right? I feel like we had a fairly strong grasp of this, right? And AppSec in this day and age really was just about looking at the app server, right? And I kind of just cared about the source code, OWASP top 10 style vulnerabilities, SQL injection, maybe a little bit of the database configuration, a little bit of secrets management, but we had a VPN, you jumped on the VPN, you did what you do, right? And you got to work. So this compared to a very simple cloud, I would say this is more of a cloud native style architecture, right? We've decided we want to open up an API for our customers, and we have a hybrid app that's mobile as well as on the browser. And now, instead of running things in this on-prem soft and kind of GUI interior, we have tons of third-party things, right? We're doing GitOps in GitHub, and third-party APIs are talking to our cloud environment. We have our CI/CD pipeline, tons of microservices, right? There's our Kubernetes cluster pulling from our registry. We're using a decoupled key vault, and we maybe have some cloud-based web application firewalls. Lambda functions out the wazoo, right? They're all over the place. And authentication, we'll just let AWS handle that, right? And then to layer everything on top of it, let's siphon all of our AWS data out of our environment and send it to commercial cloud security product, right? So this looks a lot different than this, right? I mean, not that this is overly simplistic, but these are the services that create what we know of as a cloud native architecture, right? They don't look or feel like our traditional virtual machine based or on-prem bare metal services, because they're all APIs and they can come and go within seconds. They could live for days, weeks, months, but this right here, this EKS cluster, if you blew that up into another diagram, there'd be hundreds of more components to look at, right? And that starts to be very difficult from an AppSec perspective, right? When I look at this, I'm like, where does the application security, what do I own? I like have no idea, right? Do I just own this little WAF piece? Do I start looking at the API gateway? Do I only scan the code running inside the cluster? I don't know. Those questions are really difficult. And I think my encouragement to you would be learn a little bit about all of this, right? And just what's going on, because even as a regular software developer that has nothing to do with security, you're gonna run into these words and terms and patterns pretty quickly. So we wanna make friends, right? That's really important, and we don't wanna be this barrier. That should go without saying. We should all be friends. We're working towards the same things. And being aware of blind spots. Kubernetes is one giant blind spot. If you haven't noticed, the more you know, it just feels like you just can't get to the end, right? There's just all of these things piled on top of one another, all of these different components, and these blind spots are going to be what eventually gets you owned, right? So just know you have them and know you're working towards them. And we're all beginners, we're all learning, definitely myself included. I've learned that over the past 2 to 3 years. There's a lot to learn in this space. Adapt and evolve, right? Change your job role and practice if you can. So this is a little utility I wrote probably like a year ago called KubeGoat. It spins up an intentionally vulnerable Kubernetes cluster in, well, any cloud, but mostly GCP. And Rhino Security Labs put out a really interesting CloudGoat AWS environment that you can use. And the OWASP serverless goat, if serverless is your thing, is actually pretty cool. It gives you a couple Lambda functions and lets you test them and play around with what a misconfigured Lambda function would be inside of Kubernetes, or inside of AWS, sorry. So that's it. We have like 5 minutes for Q&A. You can email me there or find me anywhere. Come talk to me after. Any questions? Almost hit my time. Yeah. Uh-huh. So the question was, are there any good templates to start with to kind of know you're at least have a foundation that isn't completely flawed? All the cloud providers, right, have their own things, CloudFormation templates, etc. The one place I would send you would be Gruntwork, gruntwork.io. They have free they claim, you know, battle hardened, battle tested Terraform templates, CloudFormation things, all sorts of stuff that's really, really good, templatized, easy to use, great start. And they have a subscription you can buy too that's pretty reasonably priced, and if you want to keep with their updates and things like that. So Gruntwork is outside of the cloud providers, probably the best place to go. Any other questions? My career has been just a series of mistakes, except for coming here. No, I think they're hard to say they're mistakes because you find them after and you're like, well, our system's complex, I made a mistake, and it's rarely one person. But yeah, I was in charge of AppSec at a company, and we got, you know, bit by a pretty large SSRF bug similar to what we've seen, and I was the AppSec person that probably spent way too much time building out the automation and all the plumbing that I didn't actually find the things I needed to find. which has kind of made me turn into not a pessimist, but somebody who, I've changed the way I view things. So I don't know if that's a mistake, but it was a learning opportunity, we'll call it. So, but in infrastructure, I did make one mistake. I turned on a security product at a large consumer-based mobile app company, and it was a security tool, and I didn't vet it enough, and I took down a third of all of our production traffic for half a day. Literally lost like $1 million, probably. I have no idea. It wasn't good. That was a true mistake. But I've learned since then to just be a consultant. No, just kidding. Any other questions? Cool. All right, well, thank you so much for coming. Hopefully it's useful.